viewers, in this lecture I am going to explain about the half-life of first order reaction. Okay. So in previous class we studied about that first order reaction. In that I am explaining the differential form and integral form and some of the graphical representations also. Okay. So in this lecture we are going to see that some mathematical expressions for half-life of first order reaction. So first you know that half-life. What is the half-life? Already I am given the definition here. Okay. The time required to reduce the initial concentration of the reactant to half of its initial value is called half-life time or half-life period. So usually we are denoted by the T of 40-50%. Okay. So to give that mathematical representation, here I am using the time required to reduce the initial concentration of the reactant to half of its initial. So that means generally initial concentration you are taken that A. Okay. So it is going to reduce how much? Of A by 2. Okay. So that means 50% of reaction is going to complete. That means I am using that X is equals to A by 2 completion when T is equals to T of. Okay. So we are utilizing that mathematical expressions to find out the T of. When T is equals to going to T of, X must be going to A by 2. Okay. So what are the first order integral forms we have here? K1 is equals to 1 by T ln A by A minus X. Or I am also given K1 is equals to 2.303 by T log A by A minus X. Okay. So two different type of we are taken. So now we want to find out the T of here. So K1 is equals to T is going to become T of, okay, ln A minus X. Okay, A minus X is equals to, here X is equals to A by 2. So A minus A by 2, K1 is equals to 1 by T of ln A by 2. Okay, so we need T of is equals to ln, okay, A get cancelled, ln 2 by K1. Okay, so T of for first order is equals to ln 2 by K1. Otherwise, here when you are substituting, K1 is equals to 2.303 by T of log A by, okay, so directly I am writing A minus A by 2. Okay. T of is equals to 2.303 by K1 log 2. Okay. So A minus A by 2, A get cancelled, we left with the log 2. So what is the value of log 2? Log 2 usually 0.3010. Okay. So 2.303 into 0.3010 by K1. So what do you expect? That T of is equals to 0.693 by K1. Okay. So this is the half-life of first order reaction. Okay. So any one of the formula you can utilize. T of is equals to ln 2 by K1 or T of is equals to 0.693 K1. So the major important point is here. When you are looking for that any relationship between the half-life and initial concentration of reactant, okay, so it is independent on initial concentration. So always you must take that T of is independent on initial concentration. Okay, so that means when you want to plot a graph between T of versus A, so if A is going to change, there is no change in half-life. Okay, so we are not taking that any change in half-life. Got it? Okay. Now let's see here. Here I am given that half-life is independent on initial concentration of A. That means, suppose you have a 100 initial concentration. So 100 is going to become 50. Okay, half of the reaction is going to complete it. So the time taken for this I am taken T of. Okay. So how much of reaction is completed here? The 50% of reaction is completed. T 50% is equals to I am taking as an T of. For example, 50 is going to become 25. Okay. So again initial concentration, how much of is reduced? Half reduced. So here also half of the reaction, half of the concentration is decreasing, but half-life is not changing here. Okay, so that's why again I am taken the TF. But when you are studying zero order reaction, TF is directly proportional to A. That means initial concentration is decreasing 2 times, half-life is also decreases 2 times. Got it? But in first order reaction, that half-life is independent on initial concentration A. That means whatever it is going to change, it does not changes any percent, not only 50%. Okay, so if 25 is going to become 12.5, again we have only T off. Suppose 12.5 is going to become 6.25, again we are given the T off. Okay, so what is the mean of this one? Here the 100 is there, 100 is going to become 25. That means how much of reaction is completed? 75. So T 75% is equals to how many T offs? It is possible to write 2 T offs or not. So here I am given the relationship between that 75% of reaction to that half-life of reaction in a first order. T 75% is equals to 2 T off. So what do you expect here? It is going to become that 87.5 or not? So here if you want to give that T 87.5% is equals to how many T offs? It is must be equals to 3 T offs. Okay, like that. If you are taken that 6.25 is the left, how much of is completed? T 93.75. Okay, so 93.75% completed. How many T offs we required? 4 T offs. Okay, so this is a useful data to do that some mathematicals and numericals in with regarding to that half-life of first order reaction. Okay, so sometimes in a competitive they are giving that half-life and they are asking for the remaining one, whatever maybe 75% or 87.5 or 93.75 or 96.87, whatever the different type of one there. And sometimes they are also asking with respect of some. Okay, so 1 by 2 fourth or 1 by 4th or 1 by 8th or 1 by 16th, there is also they are giving. So for that I am given one of the table here. When you are utilizing here, to complete the 50% reaction, how many half-life is required? 1. To complete the 75% of reaction, how many we are completed? How many we required? 2 TFs. So based on this data, I am given here, you can see that. So when one half-life is there, how much of reaction is completed? 50% reaction is completed. How much of left? 50%. But when 2 half-lives is taken, so how much of completed? 75% completed. 75% nothing but 3 by 4 or not. Okay, I am given in terms of this one fractions. Here, how much of left? 1 by 4th. Okay, so 1 by 4th I am given in terms of this one. Okay, so here 12.5 left and completed is 87.5. So the fraction is 7 by 8. Okay, so how much of left here? 1 by 8, 1 by 2 whole cube, 1 minus 1 by 2 whole cube. Just you can observe this one. Okay, so you get a simple clarity, and I am given that a relation between the half-lives and some of the fraction of the reaction, how much of is completed and how much of is left. Got it? So when you are using that number of half-lives, here the reaction is going to decreasing. So after the 10 T offs, okay, after the 10 T offs, there is a 99.9% of reaction is going to completed and 0.1 is left. Nothing but in first order reaction, T 99.9% is equals to, we are taking this 10 T off. Okay, so this is one of the important relation. T 99.9% is equals to 10 T off. Got it? So along with, I am given another two important relations. Okay, for the simple numericals. After NT off, okay, whatever that we are taken, after NT off, the remaining concentration, okay, A by 2 to the power of A. After NT off, remaining reaction percentage 100 by 2 to the power of N. So these are also two important. Okay, so relations, it is useful to do that some numericals based on the first order half-life. Clear? Thank you.